Hi, everybody. Thank you for being here. I know it's probably very close to the end of the schedule, but I promise that if you're technical or interested in at least red teaming or DevOps, you're going to enjoy this. OK, this looks decent. OK, so first of all, let's talk about what this presentation is going to be about. I'm going to give you a quick overview on what a red teamer would use during a red team engagement, what is infrastructure as a code, how do we do that, what usual customization do you need in a project, and things that are still not manually done by tools. And we also have like a short demo and some extra stuff that for the people that are going to be here until the end of the talk. It's a surprise. So let's start. Because this presentation is supposed to last for about 45 minutes, I'm going to go very quick through it because I think the interesting part is the demo, actually. So if you have any question, I would ask you probably to keep it until the end, and we'll have the Q&A session. So first of all, just a few words about me. I'm a senior penetration tester at TwelveSec, which are the guys here in the first row. I'm in love with red teaming and usually like exploiting stuff, building infrastructure, doing research from time to time. I enjoy music and listening to every hi-fi system, and I'm a poker traveler, so I like traveling a lot and visit the world and meet a lot of new people. So let's go in the subject. So what is this presentation going to be about? It's going to be about how to build a resilient red team infrastructure, and I would highlight here the word resilient because that's what this is about. Also, what resource you're going to need to build this, how to protect this infrastructure once you have it up, because this is a important thing in security because you can build the most modern stuff and can be taken down in like a couple of minutes. And then how feasible it is from a financial point of view. And also what things are not yet to be done automatically and do require further work or they cannot be automated at this point. OK, so this is the disclaimer. You should not expect from this presentation to go like deep dive into Terraform coding principles. We are not going to go through every line of the code that I wrote. We are just going to talk about the main ideas and how this works and what you need to do. And also, this is not about state-of-the-art ideas. There has been previous research on this. But most of the research is, like, I would say, pretty old, and they have not been updated. And there's a lot of things that you can add more to it and make it like custom, modern, and can be used in modern red teaming engagement. And also, this is not bulletproof. But I think at the current state of the project, this is, I would say, pretty good against like most of the engagements that we have to run. And also, this is not open source yet. OK, so just a quick note, what a red teamer would use during an engagement. So what do we need? We need, of course, a C2. So this means that we need a host to deploy the C2. We also need a redirector, a public one for the C2, because we are going to call the C2 only through the redirector. And then we're going to need something to manage and store the phishing templates that we're going to send through a red team engagement. And here we usually use like EvilJinx. And then we also need another framework for handling email sending, metrics, which user clicked the email, which inputted the credentials, and this will be GoFish. And then we need a lot of domains and custom DNS entries. And I would say here probably go for GoDaddy and Namecheap because they are the biggest ones. And also like a lot of redirectors. So HTTP, SMB, DNS, anything. You can use SOCAT, SSH tunneling, Lambda function, whatever you want. So based on what I've already said, this would be like a very introductory diagram of how the infrastructure should look like. And as the operator, which is us, we should be the only one that have access to the I would say the critical infrastructure, which is the GoFish server, which stores everything mostly, and should never be accessible to anyone if they have the public IP. So if they go to the public IP, they are not going to be able to access it. And also the C2 servers, which is also supposed to be secret. So you can contact the C2 servers only through the proxy. And then we have a lot of front-facing hosts. We have the proxy for the GoFish. We have this proxy for the C2. We have a WordPress site that we are going to discuss later what this is. And we have the EvilJinx, which is supposed to be publicly available to anyone. Because if you do a phishing link, they have to be able to access it. So any user that receives the link has to be able to enter. OK, so let's talk about what requirements are needed for this project to be built. So you generally have two options. You can either have your own servers, home or at the office, which means that you probably need like a software like VMware, vCenter, or something to manage these VMs. Or you can use a cloud provider, which in this case I gave us an example, DigitalOcean, because it was used along the presentation. And then, OK, so we know how to build a service. What's next? The question is, how do we automate everything that we need to create on the hosts? One option is to manually go spin the VMs, go inside the VMs, and configure manually, like configure firewalls, DNS, install tools manually. The other option is a bit more smart, I would say. You do this one time, and then you use Packer. You do like a snapshot, and you store all those, and then you just respin it every time you need it. But then there is the following problems. OK, so we have all of this stuff. We still need scripts. Like every time we have a new client, we have a new IP, we have new domains, we have new tools. We have to still automate some of the stuff in the bundles or in the packers, because we need to go in and modify some stuff. And then let's say we install Cobalt Strike somewhere in the server. If you're going to do this through a script, it means that the license key is in the script, so it's in clear text. So if you have this project on GitHub, it's there. So you want to somehow hide your secrets for the project. And then there's the question about storage, because we don't actually have infinite storage. So we have all these VMs with different tools, different versions. How do we store them? Like if it's a VM, it might be like 30, 40 gigabytes for each VM. So it's going to be like a lot of space for each of them. And let's say there is a new version of the tool. What you're going to do? You're going to have to destroy everything, or build up the snapshot, update the tool manually, and then recreate the snapshot. So this is also, I would say, time-consuming. So you're still not automating all of the things. So we have all these problems, and the question is how can we solve them? So it should be clear that what we want from now on is to be able to spawn and destroy hosts with a simple command. We also want to be able to modify each host through code, because if we need anything else, we just modify the code and I would say compile the code, but it's not actually compiling. And then we need a way, like secure way, to import every secret. So this led to the infrastructure as a code usage for this project. And this topic has been approached in the past by multiple people creating these environments, even through Ansible or AWS CloudFormation. But this one is using Terraform. So how would the project look like? So based on Terraform principles, this is an overview of the file structure, which contains a few important folders. So I'm not going to go through all of these, but the most important one is the cloud config, the cloud init one, which is where every configuration for every host is going to be in the YAML format, which means that for every host, we say, we want these files on the host, we want to install these tools, we want to run these commands every time a host is created. So this is like the boot script that has to be run by the cloud provider. We then have to create a lot of variables that we can set like in one of the variables.terraform files, where we just have like every secret, every IP, every subdomain, every domain that we have to create. And then we have like a lot of files here that represent each of the hosts that we want to create. So we have a file for the C2 back, a file for the C2 front, which is the proxy. So we need to create all of these hosts, and here we specify what's the name of the machine, how are we going to access it, what's the cloud init file that is going to be used on the boot. And also the most important part here, I think it's also the firewalls, where we have a lot of firewalls to make sure the infrastructure is protected. But we're going to talk about firewalls a bit later on. OK, so if you spin this project, like just as simple as it is, like just do like a git clone, go fish, install EvilJinx, install everything you have. This is how it's going to look in the DigitalOcean panel. So you just do Terraform apply, everything is up, the domains are configured, you have all the DNS, you have all the hosts. You also have all the entries for the DNS, so everything is done by default by the Terraform script. And also all the firewalls are here and are easily to monitor, verify how many hosts are in each firewall. OK, and now it comes the fun part, because this was the introduction in Terraform. So now let's talk about how do we customize this and how do we make it, I would say modern and be able to be used in like a, actual red team engagement. So first of all, most of the tools comes with HTTP, so they don't support SSL. So first of all, we need to make sure that every proxy, everything that is front-facing has HTTPS. for the hosts that are hosted in the back, and no one should access it except us, we can use self-signed certificates. But for the one that are front-facing, and they would actually represent, us, like the entity, we need to make sure we have SSL certificates, and we're going to use Let's Encrypt and their tool CertBot to get those. And then we need to make sure that all the tools we use, they don't have any indicator of compromise, because if we take open source tools and just run it, they might do like, some funky stuff on the back end, and the client would be able to see like a weird header that says, hey, this is GoFish. And this actually happens. And then we're going to talk about, how do we make this environment a bit bulletproof, and this is done through blacklisting and not obscurity. So this is just a few screenshots from the code that shows exactly how the SSL certificates should be installed, how you have to set the configuration files. I would say the image in the left here is the most important one, because here we specify that this host, which is, if you can notice, is the GoFish proxy, will just act as a proxy and will redirect anything to the GoFish server, which even though is on HTTP, but we don't actually care, the front proxy is HTTPS, so everything that is related to GoFish is HTTPS. And these are a bit of commands that are used to to configure Apache, have all those enable SSL, generate the certificate, place them in the right directories, and so forth. So this is for the proxy. I would say it's straightforward how to set it. So now let's talk about the indicators of compromise, because this is a big deal. So we use open source tools, and we need to make sure that before we use them, everything is fine. So for GoFish, there are a few indicators that are publicly available. So if you research about this, you're going to find them in different places. One of them, I think there was one talk about having fun with favicons and doing like an MD5 on different aspects of a web application and seeing if they match like a known database. This also happens for the default 404 page, which GoFish has. So if you do like an MD5 sum and you compare to like the database of known application, we know it's GoFish, even though the banner doesn't say GoFish, like anything else doesn't say it's GoFish. So we have to modify that. Then we need to make sure that there are no custom errors for GoFish that might tell any scanners on the internet this is GoFish. So we want to make sure we override those custom errors. And then, as I said before, because GoFish sends emails, we want to make sure that what it sends, it doesn't add anything to the email. Because in most cases, when you go to the email and go show original email, you go view the headers, and if you see any custom weird header, that might be like an indicator there is something suspicious happening. So in the case of GoFish, there are a few headers added to each of the emails sent. So in the email headers, you would find this specifically from GoFish, and that's how Microsoft or whatever mailbox is the destination user would be able to know this is coming from GoFish, and they will probably block it. So we need also to make sure we modify this. So this is the actual stuff that we have to modify, but there are projects that already have this, and they also implement like a Docker image. So even though this, I tested this and this works, I would recommend anyone, before taking anything from internet, just make sure you double check it and make sure it's removing anything and it's not adding anything. So if you want to check this project, Sniffy GoFish, it usually implements everything that I already mentioned. So now let's talk about the EvilJinx, which is the, I would say, main framework for phishing. It needs a lot of customization. It had a lot of ISEs. Nowadays, it's already in the version 3, so we're also going to tackle with that. So first of all, the EvilJinx 2, which I hope some of you have heard of this tool, is just a man in the middle. And back before we were doing like the phishing templates, like static HTML with some JavaScripts, but they were not able, to make sure the username is valid, the password is valid, and if there was like any 2FA, they could not, go through that with the user, like prompt it, give me the 2FA. So we have these that actually act like a man in the middle, and the user is on the EvilJinx page, but in the back, EvilJinx goes through the original page, which might be like Google login or Microsoft login, and everything that you input on EvilJinx, they would forward and they will respond back with, the answer from the actual site. So if you input like a wrong email address, it's going to say, hey, this doesn't exist. So the question is this man in the middle adding anything, more than it should be? And the question is yes, because if you're going to see like in the line 353, there is a weird byte sequence, which like if you do CTFs, you're going to realize this is weird. So why do we have these, hex bytes, and then later on we XOR them? So what's in there? And if you're going to inspect this, you're going to see that EvilJinx adds a header for every request that it proxies, and the header contains X EvilJinx. So it's easier to detect that there is a proxy and it's EvilJinx in the middle of you and the destination. And they didn't stop here, so they wanted to make sure that they do it one time in hex and then they do it in decimal. So they did it again. They XOR again and they add a new header. And they also named the function "can't find me." So for people that are curious to find these Easter eggs. So now what about the new version of EvilJinx, which is, I think it's like 6 months from now, from it release time. So they said that, okay, we are not going to do the weird bytes because it's obvious. We already did it in the previous version. So now we are going to do just like some new functions that simply add the header EvilJinx again, but we are going to do it like, I would say, a bit more obfuscate. So if you look down in the function get home directory, they are just replacing the .e with .exe, and the home directory for EvilJinx is, of course, EvilJinx. It's .EvilJinx. So when they replace that, it's going to result in EvilJinx. And this is a header that it's actually added some lines above. So again, they do the same stuff, but in a different way, just to make sure, maybe we didn't find it. OK, so this was about the ISC. So now let's go about how do we protect the environment. So I would say, first of all, we have to blacklist the internet in probably a calculated way. So this is a few confidential information that both Google and Microsoft scan the entire public range daily. And they map every domain and service. That's how they easily detect any static phishing template. So if you spawn an HTML phishing template today, until tomorrow it's going to be down because they found it. And they use all this scanning to make sure they can classify data, they can store data, and then they can later tell, hey, this domain is malicious. This IP has been seen before. This has a phishing template. This is not good. So there is a but for this. So they are scanning us, but they have a known public IP range. So this is good, because we can block them. But there is another twist. So let's say it's not only about Google and Microsoft, but there's other vendors, like probably any antivirus, any threat intelligence company, any EDR, anything on the market that is doing the same stuff. Not to mention like automated bots on AWS and other stuff that are scanning the internet continuously and looking for vulnerabilities. So there are a lot of people scanning the internet, and we don't know their IP. So how are we going to block them? Because we don't want them to allow to view us, whatever we have on the infrastructure. So first thing, we know exactly what to whitelist, because we know exactly who should be able to access this. This is us, the user. So my IP, my home IP, should be able to access this. This is the operator IP. But for the other users that are the victim of the emails, we don't know exactly where they're going to access this email from, which is going to be their end IP. So the question is, OK, so let's spawn a phishing template online. Let's leave it for like 7 days. And then let's see who actually went and visited the page, because that's not going to be a regular user. This is only a scanner, because a user would not every day going and clicking every IP and trying to access the domain. So this is only a scanner. So after like 5 to 7 days, we can get a list of possibly 90% of the world scanners that are on the internet. So then we can block them because we know the list. So this is the result after 5 days. I just left like a easy template online. I gathered like, this is a lot of IP. Like I should mention that the IP mask is like, usually it's like either 24 or 16. So there's like huge IP masks that are scanning the internet. OK, so we talked about most of the stuff. So what about how feasible this is? I would say from the beginning, this is very cheap. I use Terraform, which you can also use to the local deployment or cloud deployment. And I see maybe some of you said, hey, you want to protect the Cobalt Strike license, but you said you are going to input the license key in the Terraform variables file. And I'll be like, yes, but we can store it on the cloud, and it's safe because it's not in the project. And this is free. Like for 500 resources per month, you don't have to pay any money. And for this simple project, it's only like 30 resources. That's all you need. So we can use Terraform for free, everything that it has included. Cloud, everything is secure. I mean, not everything, but most of the stuff are secure. And for the DigitalOcean, we just need 6 hosts. And the cheapest one is like $5 to $6. So we have like $30 per month if we have like an engagement that needs these hosts for 1 month. So this is, I would say pretty cheap. And we have the power of, destroying, recreating every time we need. Okay, so now the question is what's left? We talked about what we automate, what we have, how Terraform helps in this process. So the question is what's left? So we still need to buy the domains. This is one thing. But they're like platforms like GoDaddy, Namecheap, they have some API support, so you can buy the domains. You also have to pick them correctly, but this is another discussion. You also have to migrate domains from GoDaddy and Namecheap to DigitalOcean or Google Cloud Platform, or you can buy the domain from Google Cloud and just use it inside your project directly. But I had to do this manually in DigitalOcean. And then we have to create the SMTP relay, which is going to be the server that sends all the emails. So GoFish is going to use the SMTP relay to send the emails to the world. And then, OK, we have the emails, but it's going to probably hit the inbox. And then it's going to hit the inbox, but we have like a custom domain that it probably has like a reputation of 0, if not like even negative. So how do we build a reputation for this? And then in the end, for people that have played with GoFish and EvilJinx, first of all, there are 2 separate products. So if you want statistics in GoFish for people that inputted credentials in EvilJinx, you have to manually code this because this doesn't exist. So this only works in GoFish if you use GoFish static HTML phishing websites and you store them on GoFish, and GoFish knows you input username and password. OK, so first, SMTP relaying. This is a big deal because when I started this project like 1.5 years ago, you can spin up a VM in cloud. It doesn't matter the provider, and you can install the tools, install postfix, and configure it to be a SMTP relay, and you just start sending emails to phishing stuff, abuse this option. But they realized it, and they were like, why do we keep allowing SMTP traffic in our cloud environment? You shouldn't be able to turn our cloud host into like a spamming stuff, because you would be able to destroy and recreate, so we can block that spam. So they did this. So the question was, OK, how do we mitigate from this? What do we do? What are the options? And one thing is to move the infrastructure, or at least the SMTP relay, from the cloud point of view to like a local deployment, and use Ansible, spin the VM up in your own server home, and use the SMTP relay. This has some downsides. The other option is to use like a third-party SMTP relay, for example, Google or Microsoft, because they can help you send emails. But then I'm targeting employees on Microsoft and Google, and I mean, having mailbox there, not targeting Microsoft, having mailbox there. But they also have visibility over my emails because they are the SMTP relay. So that's not exactly what we want to do, because we don't want the same people have access to the emails and also receiving them in the mailbox. So let's use a third-party SMTP relay, like, for example, SendGrid. And hopefully they don't send as much data as Microsoft and Google does. And it's very easy to use for up to 100 emails per day, and it's free. But if you want to go more, it's not that expensive. If you want to send like this, like corporate level, like a few hundred IPs, it should be fine. So this is how you would be able to configure SendGrid. You just get like an API key. You go in GoFish. You go create a sending profile. You input the username API key and the password, the API key value, and you're good to go. Everything goes for SendGrid. So now, domain reputation, another thing that it's important, because we are sending emails, we have the infrastructure, but the domain was just purchased a few days ago. It has 0 reputation, so it's not that good for us. So it's obvious that when you send an email, the domain reputation takes a big place into if the email is going to be marked as phishing, going to junk, deleted, or maybe even denied by the mailbox, because the mailbox can deny an email. So how do you get a good reputation? That's the question. So I would say the silly response for this is just buy a domain with a good reputation. But this is very rare. Like, you have to monitor specific domains when they expire. They were used for a legitimate purpose, and then you just purchase them when they expire. But you have to be there. You have to create some scripts to be able to monitor this. And then you can also build your own reputation, which is a bit harder, because first of all, we are going to use WordPress to spin up, like, I would say a landing page, because that would be the front face of our domain. That's the business that we're running. If you want to be a bank, we're going to have a WordPress with some banking details. Hey, this is a bank located in USA. We do this business, so we have to be legitimate. And then we use ChatGPT to populate with data, pictures, contact details. They are all fake, but it's there. And then if you have time, you can use like social media marketing, SEO, other stuff, create a blog, make sure it's legitimate, everybody knows about it. And there's another option called warm up your mailbox, which means that you paid someone that has a lot of mailbox in different providers, and they somehow in 90 days ping pong emails from their mailbox to the mailbox they have also. They open the emails, they respond to it, and that's how they build a reputation on your domain. So this is a paid service, of course. But if you don't have time to perform all the blog posting, social media marketing, this would be like a easy and fast way to make sure emails are hitting the inbox. So what if you don't have a lot of time? That was the question. So first of all, besides Google and Microsoft, there are a lot of vendors online that you can use to manually go there and find information about your domain. For example, you can go to VirusTotal. You can go to, I would say, Talos Intelligence, which is another platform. There's a lot of vendors that you can ask, what's the reputation of this domain? So the question is, how do we get a good reputation for these vendors? And the answer is, you either wait for them to mark you manually on the database, or you submit a request to them and say, hey, I have this domain. Can you flag it as banking or anything else? So the question is, okay, so we have a lot of vendors. We want to automate this because that's the main purpose of this presentation. So we can do some scripts and go in the vendor website, submit a category request and say, we want this category for our domain. Please help us. We have a WordPress. We have everything is legit. We have a business. There is a tool that does this, but the problem is that this tool has not been updated in like 3 years, and every vendor does have like CAPTCHA implemented. They change the form, and everything is changed. So you have to manually, update every time, make sure the vendors did not change where the submit request is. So, the idea was there, so ignore the red part there. The idea was there, so it's easy to re-implement everything. Everything was in Python, so we use Selenium. We use like a VPN to switch between IPs, because if we do a lot of requests in different vendors, somehow Google knows, and it's like, okay, why are you doing so many requests? We're going to change the IP, so, okay, you cannot see us. And the next, we're going to use like CAPTCHA solvers that are publicly available to make sure we can bypass the CAPTCHA. So the question is, okay, this sounds like I would say, dumb idea. Okay, we submit a request. But what would the vendor say when they see like, hey, this is my domain, please mark it as banking? And fun fact is that a lot of them just say, okay, we've done it. We send you an email back, they say, hey, we have viewed your request and we have manually reviewed it and have concluded that we are updating our database and you're going to be banking, whatever. So, some of them did not say that. Some of them did not send an email, but they still mark it as whatever we wanted. Some of them said it's still newly observed, so they did not take a decision. And some classified this as IT, which honestly, I don't know exactly what it means until now. But if it's not malicious or phishing, I'm fine with the IT also. So this would be like a very, output, a very short output of the tool that we have created, which mainly takes all the vendors that we specified, a domain name, and then they go, first of all, and they check the category, and then you can use a second parameter to submit a category request. And you see that for the domain that it's highlighted for a good purpose, we were successful in submitting requests, and a lot of the vendors said, hey, this is health and medicine. Why health and medicine? Because we created the WordPress, and this is the WordPress. It's a daily health log if you want to check it out. It will help our campaign. So what did the vendors exactly say? That's another question. Okay, so here in the left part, we have some people that say, hey, this was manually moved by a specific guy working for, one is Bright Cloud, the other one is Lightspeed System, and they said, hey, we have viewed it, everything is fine. The other one say, hey, we have updated the database. As I mentioned, some of them did not send an email, but they still marked this, whatever we wanted in the database. You just have to go and check it. I see someone wants to take a photo. Okay, so now the extra, because I said before that EvilJinx and GoFish are separate products and on separate hosts, and they don't work together, so you manually have to code it. And I find it useful to look through the code of GoFish and EvilJinx, maybe for future references, but see how easy this is to implement or how hard it is. And there's a few changes that you need to do to have this happen, because these are separate hosts, and they should be able to operate on each other's database. So you have to migrate GoFish from SQLite, which doesn't allow like multiple concurrent session on this. It doesn't provide that, to MySQL. They have documentation on how to do this. You also need to make sure you have firewalls enabled so that EvilJinx can contact the GoFish database and nobody else. And then you have to make sure that when you send a campaign in GoFish, for every user, they have a unique identifier. And you need to make sure that EvilJinx knows the unique identifier, because otherwise, it cannot identify which user inputted the credential and which one accessed the link. So we need to also pass these details to EvilJinx from GoFish. And then we start, simply query the database for GoFish. We look in the tables, we see how they look. We create the events, and we updated everything to, to have username and password when you input in EvilJinx. You also have IP, and, later on we'll also do like maybe session cookie because that's what EvilJinx is good at, not only username and IP because that's not exactly useful. Even the password, like if you have 2FA, it's not going to help. But if you do the whole process with EvilJinx, you get like an authorization token or a session cookie. So we want to make sure GoFish also stores that because right now it's only on EvilJinx. And next iteration for this would be to make it better, make sure we store these session cookies in GoFish also, not only in EvilJinx, and then also add some sort of captcha to make sure that people are not entering the URL like with a bot. Like if they have our secret path, they're not going to be able, to click it a lot of times. So we would implement some sort of Cloudflare protection. And then because we are protecting against Microsoft and Google, so when they're going to enter the link, they are not going to see anything. But they are still, when the user receives an email in mailbox, by default Microsoft will go, will see there is an email, will see there is a link, will click the link, will see there is nothing there, and will come back. And in GoFish, this is already marked as user clicked the link. So this is a metric that it's not useful at this point because the user did not actually click the link. It's like an automated software in the back. So we need to make sure we remove this metric from GoFish. Okay, and I'm going to also show a short demo of I think it's like 1.5 minutes on how to create a campaign and how to send it. How effective is this blocking the internet and how is the EvilJinx workflow and how this integration works. And before going to the demo, there's a few references that if you're interested in this topic, you should look into. So first of all, let's go in the iRead.team because this is the initial paper that I've used for this project. And they had the inspiration for this, but they did it I think in Amazon, in AWS. And then there's this Rasta mouse that also did like a similar project for Covenant as a C2, and they built the whole infrastructure with Terraform. And then there's also the Evil GoFish project, which somehow they do the same stuff by linking EvilJinx with GoFish, but they have a different approach because they place everything on the same host and they have an Nginx in front, which I would say probably it's not recommended because every resource should be in its separate environment, isolated from each other. And if they are on the same host, it means that if one is compromised, it's going to have access to the other, so it's not recommended. And if you're interested more in phishing in general and what are the modern attacks and how we can bypass them, there's a good article that I wrote in the TwelveSec blog. You can go check it out and see how people usually protect against phishing and what we can do. So now I'm going to switch to the demo that I have. Hopefully it works from the first try. So I think now someone should change. Okay, great. So this demo will already show when the environment is created and how a campaign is created in GoFish. We have to set the URL, which will be the first link that is going to be displayed in the email, and which, when it will be clicked, it's going to store everything, such as the person that opened the email and the person that clicked the link. So we know already two metrics. So we know it was opened and clicked. And then after the click, it's going to go to GoFish, and it's going to redirect to EvilJinx, which was in a separate host and a separate application. So there's a few things here that probably not going to be noticed, but I think I did show later on that, first of all, the first metrics that you're going to see here is the automated stuff from Microsoft, which is going to take a lot. The email is going to be delivered. The email is going to be opened by Microsoft. The link is going to be clicked, which is not the user yet. And then we are going to see an event in GoFish which says IP blocked. Yeah, right there, 4094. If someone knows about this IP range is Microsoft. So we already know Microsoft tried to access the phishing link and it was blocked. So they did not see yet what is there. That's why maybe it's not marked as phishing yet. So this metric here is from Microsoft. If you're also going to search the IP, yeah, this is Microsoft. But we already had this in the IP mask for the blacklist, so we are safe. And then we are going right now to open the email and go to the link and see what's happening. So you're going to see that there was a short redirect from the Office 365, the domain name that we have to the login, which changes from GoFish to EvilJinx. So right now we are on EvilJinx. We inputted the credentials. We have 2FA enabled, of course. We already can see here in the left that it says session marker submitted in GoFish. So data was already sent to GoFish, and GoFish knows we inputted this username and password. We're also going to go and set the MFA to make sure that we also can get the authorization token, because that's an important thing. And after everything is finished, yeah, we detected the authorization token and we have it stored. Okay, everything is good to go. We can go in the sessions. We can inspect the current session that we have. We have the tokens, and we can use them in the browser, like inspect this cookie and just modify it, and we have the user access. And then if we go back in GoFish, we can see the submitted data was updated, even though this was done like through manual coding and not GoFish itself. And we can go in the details, and we have metrics. So we can provide client more information about what every user did, what IP they used, and what they inputted. Okay, so this should be all. Now, if anybody has any questions, I would be more than happy to answer.
Hi, thanks for the presentation. I have a question. What would be your recommendation for protecting against this? Does Microsoft, because you demoed using Microsoft's login system, authentication system, does its new two-factor authentication mode where the website displays a number and you have to input that number in your authenticator app instead of the other way around, does that defeat this sort of attack?
So what happens is that actually Microsoft, so in the backend everything is redirected. So Microsoft sees that the actual user is our EvilJinx IP, for example, in this instance. And of course that the user would have to, they're going to receive a message or an email or a code that they would have to input. So, but at least the UI looks exactly like Microsoft would ask. I would say, like as a defense staff, first of all, Microsoft should check, first of all, from which IP is this user trying to, connect to me. And we're going to see like an IP, and then we go inspect the IP and we see, oh, this is in DigitalOcean. This is an IP in DigitalOcean. Okay, so maybe this is not the user. Maybe this is a proxy framework or something. So this would be one way to detect it.
Right, but I'm saying that Microsoft has a mode where its legitimate login screen displays a number to you, and you have to input it in the app in order to authenticate.
Yeah. Okay, that's
if this is a spoofed, if this is a spoofed login screen and not, how should I say it? If it's not in real time, it's not the
It's going to be in real time. Yeah, it works also. So the EvilJinx will show, hey, please input this number in your application. You're going to open your phone. You're going to input that. First of all, Microsoft will probably refresh, and then the EvilJinx will refresh, and they will know, this has been inputted. So they would, it's just like they are going to forward everything. So everything is going to work. There's nothing they can, change from code to password or, biometric. It's going to work the same because we are just proxying stuff, but we are in the middle, so we see everything. So that's the advantage.
Following your presentation, it is true that everyone can create some red infrastructure with a minimal knowledge or some little knowledge. Do I need only a free account on a Google?
I would say just as a demo purpose, I think you can learn Terraform in like 2 weeks and create the basic environment that I did. That's
so I can go home and
play with this, sure. If you want to use it in production, actually if you do a pen test or a red team engagement and you want to use it, you're going to have to customize it a lot. But just like demo purpose, you can create it home. Maybe you don't want to use it in red teaming. Let's say you just want to create a lot of hosts and use it for streaming.
So everyone can do it? So
yeah, everyone can do it. You just go in DigitalOcean, create an account, get an API key, and it's basically Terraform calls the API from whatever Google Cloud platform.
Learn and grow.
It's not drag and drop, but I would say it's, there's a lot of tutorials on how to do this. And the code for Terraform is not actually,
No, it's open source.
Not open source, but there's a lot of places where you can go and, they can give you like a lot of code snippets. Like even in the references that I gave you, they're going to have most of the snippets for AWS and Google Cloud Platform. And the changes to go to a different provider, it's like minimal. Like, I can even show you, like, if you want one of the codes, it's like 5 lines to spin up the host. The problem is not spinning the host. The problem is how do you customize the host, which is the cloud init file. So the cloud init says what is going to be installed there. And then you just need like, bash skills. I want to install these tools. I want to set this firewall. I want to do this. So this is the custom part. But just spinning the host is like 6 lines and you created the host. That's easy.
Okay, thank you.